Okay, today, very briefly, we want to do a review here, just as a reminder of the seasonal effects. Seasonal effects are due to the Earth's tilt. And the farther north you live, the more radical the seasons, or dramatic the seasons. Living near the equator, you don't have the great change in seasons that we have at our locations. So starting on the right side of the diagram that's showing here, we have the northern hemisphere tipped away from the sun, and so it receives just a little sunlight, not very strong, and we have seasons. We have the winter season. The two other across from each other, two other Earths across from each other, these are the equinoxes. The sun is pretty well distributed across the face of the Earth. The temperatures aren't very dramatic between temperatures. And then we get over here to the first day of summer, so that at that point the Earth's tilt is toward the Earth. Some folks think that the Earth tilts back and forth, that it goes back and forth. And of course not. The Earth is pointed in the same direction in space, so that at sometimes the axis is tipped toward the sun, 6 months away from the sun. So the seasons are caused by the Earth's tilt. One dramatic effect, but very, very small over a human lifetime, is the term precession. By this definition, it's a slow circular motion of the Earth's axis. You could describe it also as a slight wobble. Notice the child's top. You've probably seen a top before. It does not spin perfectly true. That axis wobbles a tad. And so the moon and sun pulling on the Earth causes the north celestial pole to point to different spots in space. So the Earth slightly wobbles, and we get a precession effect. And in the sky, what occurs that the celestial pole points at different spots in space. Polaris happens to be very close to the celestial pole right now, and is our North Star. When the Egyptian pyramids were being built, Thuban was near the North Celestial Pole. But other times, notice in the past, if we go backwards, that we had no North Star, and even into the future, there are no bright star near the North Star, or near the North Pole to have a North Star. So sometime in the future, the bright star Vega will be near the North Celestial Pole, and so will the star Deneb, which are summertime stars now in the summer triangle. So precession causes the Earth to slightly wobble, but mainly over our lifetime and our descendants' lifetimes and our ancestors' lifetimes, there are essentially no change in the stars that are above the North Celestial Pole. Again, this is caused by the Earth's wobbling, the effect of precession. This is an interesting photograph of the moon. This is certainly a photoshopped moon into this picture of the mountain. Why would you think that might be photoshopped? Well, I'm just asking sort of the question out loud. It's really is in comparison to that mountain. It's a photograph. And with the moon that close to the horizon, the Earth's atmosphere is orange rather than the typical grayish white that we see when the moon is high in the sky. The original concept of the month of 30 days is based upon the moon's cycle of phases. It takes approximately 29 and a half days for a cycle of phases. And so our ancestors, knowing this, they the months either into 29-day months or 30-day months to make up for that fraction of time. And so the 29-day months were called empty months, and the empty, like an empty cup. And the 30-day months were called full months. And originally our year was based upon 12 of those months, and that turned out to be about 354 days. So this concept of a year and a month was based upon 12 lunar cycles of a 12 lunar months, 54 days. Many religious calendars are based upon a 354-day calendar based on 12 moon phases. The moon phase names are this. The cycle typically starts out with the full moon phase, or the new moon phase rather. As the phase grows in size, in other words, the moon is always the same size, but at the new phase we see because facing the Earth is dark, and then we see a little crescent, and then we see it half full, and then it gets more than half full, and then it becomes full. That term for more than half full is called gibbous. That's the name of a shape. And like last night, that nearly circle of light with the planet Jupiter was there. So during this left cycle of phases, we use waxing, meaning that the phase is growing. So from no light to a little crescent to a half full moon to a more than half full moon to a full moon, that's the waxing phase. It takes about 2 weeks for that to occur. And as the full moon occurs, then the sunlight begins to diminish on it, and so it tends to go backwards. And so the light tends to shrink, more than half, back to a crescent, and back to the dark again. So this side is said to be the long A, waning crescent moon, waning gibbous moon, and sometimes third quarter is called last quarter, a last quarter moon. Here is a diagram very typical to show you this. On the right side, the sun is out in this state. So notice that the sunlight is always on the right side as we look at the moon. We're way up in space. So as we see this, the moon is always lit up from the right, and also the Earth is lit up from the right. So that's daytime. And obviously over here is the nighttime. As the moon revolves around the Earth in its cycle of phases, it displays these different shapes to us. So we happen to have a thin crescent, we happen to have a half full moon, we happen to have a gibbous moon, and then it goes full. It's really technically full only one night. It's exactly opposite the sun for only one night. And then it's technically gibbous after that point. It looks almost like a perfect circle, but it's actually a full moon one night. So from new moon to full moon is a little over 14 days. I'll put a plus in front of it. Half of 29 and a half days. Then as the moon continues its cycle, it then begins to show us less. The gibbous phase, the half full moon, the crescent moon, and back again. So it takes the 29 and a half days, that half is rounded off, 29 and a half days for the moon to display to us this complete cycle of phases. So the moon is really crescent for more than one night. It's really crescent for more than one night. It starts out as a little thin crescent in the west, and it grows larger and larger. It's half full, really only one night, and then it goes gibbous. It's half full when that line that separates day and night, the light that separates day and night on an object, is referred to as its terminator. Is referred to as the terminator. And so when the terminator is straight like that, that happens to be the half full night, same way over here. So it's first quarter and its last quarter. These are the moon phases. You should be able to identify them from a drawing, from a picture, when given a name, when given a picture of them, the moon phases. There is a difference between the types of months. There are actually a couple of types of months. One is referred to as a sidereal month, and the other one is referred to as a synodic month. You and I are used to this synodic month of 29 and a half days. A synod, S-Y-N-O-D, a synod is a meeting. That happens to be the word for meeting. And many groups, before they had calendars and clocks, would call meetings moon phases. So synod has the word related to meetings in it. The other term is sidereal, and sidereal means starry or a star month, a month by the stars. And the difference is a couple of days. The difference between a sidereal month and a synodic month. Quite simply, a sidereal month is actually a month where the moon revolves around the Earth by 360 degrees. It's technically one complete revolution. And notice in this diagram here where the Earth is revolving, we're looking at this from the Earth revolving around the Sun, that the moon is going from here to here. From new moon, the moon will revolve as the Earth revolves, and in 29 and a half days, it will be back lined up with the Sun again. That's 29 and a half days. So from new moon to new moon, that is the synodic month, or full moon to full moon. So it's really any time there is a one phase back to the same phase again, full moon to full moon, but totally we start this out as a new moon, talking about the start of a month. However, the moon actually revolves 360 degrees. If you notice where the moon is on this diagram, if you think about it being a clock face, and that being 12 o'clock noon, notice that it's back to the same place on the orbit less than 29 and a half days. That is really a 360 degree revolution around the Earth. And so this is the sidereal month, or the star month. If there is a star right behind the Sun over here, then that star will be lined back up again with the moon 21.3 days later. And so the term sidereal month, or the time for one revolution. So the sidereal month is the time for one revolution compared to the stars, or 360 degrees around the Earth. And the synodic month is the time for a cycle, a set of moon phases, measured as from new moon to new moon, full moon to full moon. And we tend to watch the synodic month happen in the sky. The sidereal month can be observed, but it is not as easy as the sidereal, as the synodic month, to watch that moon. Also associated with this are the opportunities for eclipses. This diagram is one that's not very easy to look at, but in a sense, let's see if we can simplify it for you. The ecliptic happens to be the plane, orbital plane, think about your geometry for a moment, the orbital plane between the Sun and the Earth. Remember, in geometry, you need 2 points to define a plane. 2 points to define a line, 3 points to define a plane. So here we have a plane set up by the Earth on this side, the Sun, and the Earth on this side. So we have a plane, this like a paper plate or a CD. This thing between the Earth and the Moon are in the same, they're on the surface of the plate. However, the Moon's orbit is tilted by an angle of 5 degrees. And so every time the Moon is either at the new phase or the full phase, we do not have eclipses. We only have eclipses when at new or at full, the Moon's shadow touches the Earth. Most of the time, the Moon's shadow does not touch the Earth at that phase. It either goes above or beneath, and we don't have an eclipse. Quite simply, an eclipse is a shadow. It's a shadow of the Moon or a shadow of the Earth. So at these 2 particular times noted, the one at the bottom and the one at the top, the Moon's shadow would touch the Earth. We would have a solar eclipse at this point. I'll put an S here for solar. And over here, we would have a lunar eclipse. That's where the Moon goes into the Earth's shadow. These other 2 occasions, we have any shadow touching another object. So there are no eclipses when this Moon is new or full, and the same on the other chart. No eclipse. So the Earth's tilt, the Moon's tilt rather, the Moon's orbital tilt is what causes this to be different, in the fact that different meaning no eclipse every month, or 2 eclipses, not 2 eclipses every month, a lunar eclipse and a solar eclipse. Lunar eclipse is when the Moon is blocked out. Solar eclipse is when the Sun is blocked out. The Moon blocks out the Sun, and the Earth blocks out the Moon. Those are the eclipses, and the tilt of the Moon's is what causes that. A solar eclipse. This is what is referred to as a total solar eclipse. The new Moon is directly in front of the Sun. The Sun is blocking out, the Moon is blocking out the Sun, and for the short period of time that can be roughly about 7 minutes long, we can see the Sun's atmosphere. The Sun's atmosphere is always there, but it's just the fact that the Sun's surface is so bright that we normally cannot see the atmosphere of the Sun. The Sun does have an atmosphere, but not like ours. It's a gaseous region surrounding the Sun. We'll talk about that when we talk about the Sun, when we describe the Sun for you and what we understand about the Sun. So this ring of light, this glow rather, it's not really a ring. It is kind of ringing around this whole situation. But this glow is called the Sun's corona. And that means this is the Sun's crown. That's the Sun's corona. And this spectacular event You can see the sun's corona for just a short period of time, and on some occasions you can see bright stars back here behind the sun, and even planets during these eclipses. So this is a total solar eclipse. And this one occurs in this fashion. If we could take some lines and draw them from the edge of the sun, we will see that the moon projects a shadow. And that shadow, if we could cut through it here and look down into it, there would be a center circle and an outer circle. The darker circle is called the umbra. And if you happen to be standing in the umbra of the moon, you see a total solar eclipse. If you're only in the penumbra, the outer part, the penumbra, you only see part of the sun covered. So if you're only in the umbra, then you see this. The umbra gives you the total solar eclipse, and the penumbra gives you the partial eclipse. So if you're only in the penumbra, you only see an eclipse. So if you're standing here, when the shadow comes across, you're only going to see a partial eclipse. Partial eclipse. If you are standing here and the shadow comes over you, you're going to see a total eclipse. Shadow comes racing across the Earth's surface, and a person can be standing in the umbra for a maximum of 7 minutes. That is there are actually 3 types of eclipses, and we'll get to the third one momentarily. Partial and total. Here is the third type of eclipse, and that third type of eclipse is referred to as an annular eclipse. This little diagram is interesting because there are actually 5 pictures of the sun on one picture. Five pictures of this eclipse. So notice over here we have the total eclipse. Here, however, we have a partial eclipse and a ring eclipse, or an annular eclipse. Annular means ring. It's a ring eclipse. It's not annual like every year. An annulus is a ring. So this happens to be a ring eclipse. This is a ring eclipse. And let's briefly describe that a little bit further. In this particular case, we have the sun rising. So the Earth is rotating and the sun is rising. The moon in its orbit is slowly moving to the left. So we have sunrise, and then we have the moon is here. It's a new moon. So it's slowly moving to the left on this picture in its orbit. So it's moving this direction. So notice more and more of the sun is being covered by the moon, except at the maximum part of the eclipse, there's still a little ring of sunlight surrounding the moon. The moon's orbit is not a perfect circle. And so sometimes when this occurs, when the moon crosses the ecliptic and it's a little too far away from the Earth, the moon will not be a perfect match. And so we'll end up with this little ring of sunlight that we call an annular eclipse, a ring eclipse. And then the sun continues to rise, and the moon in its orbit continues to move to the left. And so we get the whole event of the moon starting to cover the sun, more of the sun, a ring eclipse, partial, and partial. So a person in the umbra would see the total eclipse, except this case the umbra is really too far away from the Earth. We are at a ring eclipse. So to see a total and to see a partial, you get a total and an annular. you get a partial eclipse along the way. A ring eclipse, an annular eclipse. So there are three types. There's the annular, there's the total, and there's the partial solar eclipse. It's possible only to see part of the sun covered even at the maximum time. And this takes a couple of hours for this whole event to occur. Here is another example of the diagram that shows an eclipse along a satellite photograph of the shadow on the Earth. And this is some good examples where we have the eclipse occurring and satellites taking pictures of that. This diagram happens to be from NASA, and they track eclipses as part of what they do. And notice this is eclipses from 2001 to 2020. And this shows us total eclipses are in blue, and the ring are in red. The next ring eclipse visible from North America is in the year 2012. And that is the eclipse that's starting in the western part of the United States on this diagram. It actually starts out in the ocean. And comes into the western part of the United States. This shadow right here. So there will be a ring eclipse visible in the American Southwest, and most of the U.S. will see a partial eclipse. The area around it will see a partial eclipse of the sun. The next time a total solar eclipse is visible from North America is this blue line, 2017, in the summer. And it will come right across the Midwest, the umbra will, and most of the U.S. will see a partial eclipse during this time. So we don't have many eclipses visible, and most of the eclipses occur over the oceans. Earth is mostly covered by water, so that is where most of the eclipses occur. The last eclipse was just a month or so ago, and it's over here on the right side of the map. It was in Asia, China, Japan. This was the last. I've got the wrong line there. It's this eclipse here. This eclipse here is the last month's eclipse in July. The lunar eclipse occurs a little differently, and that is when the moon goes into our shadow. Notice, as I tried to sketch out there before, we have the darker core of the umbra, the lighter core of the umbra, and so the moon can actually go through that shadow any number of ways. But here's a sort of a simplified diagram. Top diagram shows the moon only going through the penumbra. The penumbra is not very dark, and a penumbral, notice the term over to the right, a penumbral eclipse is really not very dark. Most of us, for the most part, cannot see any difference in the darkness of the moon. Not very spectacular. Most of us don't notice anything going on. A total eclipse is when the moon starts into the penumbra and then it goes into the umbra and is in there for about an hour. And the moon looks a little coppery color. For us, this is not its natural color. This is because some of the sunlight actually gets refracted around the Earth. On this bottom diagram, if I can sort of draw this, the Earth's atmosphere bends the light, and primarily that's red, orange. And so sunlight gets refracted or bent through the Earth's atmosphere and causes that to glow a little orange. And then the moon comes out of that eclipse and then leaves the shadow. February, a year ago, there was a total lunar eclipse visible for us in our. And the other one is a partial eclipse. The moon goes into the penumbra and goes only a little bit, part way into the umbra, and then comes back out. So you would see just a little piece of the moon darkened, and perhaps even a little coppery colored, depending upon how far it went into there. So there are three types of lunar eclipses: the total, the partial, and the penumbral eclipses.